All right, today we're going to be talking about Lecture 31, direct variation. So there are two types of variation. There are two types of variation. As you can probably tell from the title, the first type is called direct, and the second type is called inverse. So there are two different types of variation, direct and inverse. Direct variation is going to be modeled by the equation y equals kx, where k cannot be equal to 0. Inverse variation is going to be modeled by y equals k over x, where x cannot equal 0. So for direct, you're going to be multiplying, and for inverse, you're going to be dividing. So you're probably wondering what k is. K is called the constant of variation. The constant of variation. And for today, since we're talking about direct variation, k can never be 0, but it can be any real number except for 0. Now, when we're talking about direct variation, we have y equals kx. What we can do with that is we can divide both sides by x. So when I divide both sides by x, they cancel out on the right side, and the x is going to show up on the left side. So we're going to get k equals y over x, which means the ratio of x and y stays the same, or the ratio of x and y stays constant. And that constant, of course, is k. So there are two different types of variation. You only need to know one for today. That's direct variation. Direct variation is going to be given by the equation y equals k times x, where k can never be 0. But it can be any real number except for 0. And then inverse variation is going to be y equals k over x, where x cannot be 0, because then you would be dividing by 0. Now, k is just a number. K is often called the constant of variation, or the constant of proportionality. In this class, we'll call it the constant of variation. And because we know that k equals y over x, we can say that the ratio of x and y stays constant. So those are the two different types of variation. All right, so how do you graph direct variation? We're going to graph y equals kx. So if I was given an xy plane, where you know that x is going to be the horizontal axis and y is going to be the vertical axis, we usually graph it as a straight line going through the origin. So it's always going to be a straight line that goes through the origin. 0, 0. So the graph of y equals kx is always going to be a straight line. Now, in this case, y equals 1x, or we can call that y equals x. But you could also have graphs that have a negative slope. You could have a graph that has a negative slope like y equals negative x. That would look like this. So this is the x-axis, and this one is going to be y equals negative 1x, or y equals negative x, same thing. So you can have positive slope, or you can have negative slope. So it's just going to be a line passing through 0, 0. It's always going to be that way. And your slope can never be 0. So k can never be equal to 0 when you graph direct variation. Inverse variation has a completely different type of graph, which we're going to have to talk about on Wednesday. So that's direct variation. Okay, so what we want to do is we want to use y equals kx and solve some problems with it, hopefully. So we're going to be doing that on the next slide. Okay, so here's the first example. So these questions are kind of like, they're worded in a sentence, maybe 2 sentences, but never more than that. So your question is always going to be some type of paragraph. So the first one, I'm going to say, given direct variation, So the first thing I do is I tell you what the type of variation is, whether it's direct or inverse. So given direct variation, find k when x equals 6 and y equals 12. So I give you 2 different pieces of information. I tell you what x is, and then I tell you what y is. So what we're going to start off doing is we're going to write out the direct variation formula. And if you remember from the last slide, the direct variation formula is y equals kx. We start from that formula. And then what we do is we start plugging in our information, what they give us. So for example, they tell us y is 12. So I'm going to replace y with a 12. Then they tell us what x is. They're telling us that x is 6. So I'm going to plug in 6 for x. And then I go from there. So if I want to figure out what k is, I need to get k by itself. And that means I need to divide both sides by 6. And what that'll do is that'll get k by itself because the 6's will cancel out on the right side. But on the left side, all the numbers show up, and 12 divided by 6 is 2. So k equals 2. So they start off by giving you some information, and they want you to take that information and put it in the form of a formula. And then you start doing algebra with it until you find out what you're supposed to find. Okay, so let's look at the problem set. Okay, suppose there is direct variation. So I'll say suppose direct variation. Find k if x equals 3 and y equals 6. So they start off by giving us 2 pieces of information. They give us x equals 3 and they give us y equals 6. So I start off with my direct variation formula, y equals kx. And then what I'm going to do is I'm going to plug in those numbers for y and x. They tell us y is 6. They tell us that x is 3. So I get 6 equals k3, or 3 times k. I need to divide both sides by 3 to figure out what k is. So k is going to be 2. So here they're giving us 2 variables, and they're asking us what the constant of variation is. And that can be easily found. You just got to make sure you plug in the right numbers. Okay, let's move on to number 2. 2 says, assume y varies directly as x. Y varies directly as x. So you know you're going to have y equals kx. Now, if x is negative 2, and k equals 9, find y. So here they're giving us 2 pieces of information that we need. We know that x is negative 2, and we know that k is 9. So the first thing I do is I write out my formula, y equals kx. Then I start plugging in my numbers. I know that k is 9. I know that x is negative 2. So I get 9 times negative 2. So then y has to be equal to 9 times negative 2, which is negative 18. So that would be my answer. Y equals negative 18. So for all these questions, they're giving you the information and they're trying to get you to say what the missing value is. We're going to skip to number 4. 4 says, assume y varies directly as x, just like the last question. If k is 4, find x when y equals 100. So y is going to be varying directly as x. Let's go ahead and underline our information. We know that k equals 4. We know that y equals 100. That's our knowns. What's our unknown? We're trying to figure out what x is. So the first thing I do is I write out my formula, just like every single time. Y equals kx. That's direct variation. They tell me that y is 100. So y is going to be 100. And they tell me that k is going to be 4. So k is going to be 4. So I get 100 equals 4x. Now, if we're trying to get x by itself, I can divide both sides by 4 to get rid of it. So 100 divided by 4 is going to give me 25. That's my answer. And the 4's cancel out in that step. So they're giving us the information and they're telling us find the missing variable. Okay, let's look at number 5. 5 says, suppose y varies directly as x. And then what we want to do is we want to find k when y equals 5 and x equals 20. So they give us those 2 pieces of information. And then they go on to ask the additional question, what is x? What is x when y equals 8? So 2 questions in one. So they give us 2 pieces of information to start off with. They give us y equals 5, and they give us x equals 20. And they want us to find k. And then after that, they give us another piece of information. They tell us y equals 8. But we'll get to that later. So the first thing is, suppose y varies directly as x. Okay, Well, then we're going to have y equals kx. That's the formula for direct variation. K is just going to be a number that's not equal to 0. And then they tell us y equals 5. So if I know that y is 5, I can let y be 5. But they also tell us x equals 20. So I'm going to replace x with 20. And then I can get k by itself. So to get k by itself, I need to divide by 20 on both sides. So then I get k equals 5 divided by 20. If you put that in your calculator, you're going to get 0.25 or 1/4. 1/4. So that's k. And then they ask us, what is x when y equals 8? Well, going back to that direct variation, we're still going to have y equals kx. We're still going to have direct variation. That hasn't changed. So the formula isn't going to change either. But we have new information now. We know that y is 8. We also know what k is, right? We know that k is 1/4. That's going to help us. But we still don't know what x is. But we can figure out what x is if we get rid of 1/4. And the only way I know how to get rid of a fraction is by multiplying by the denominator. So we're going to multiply both sides by 4. So by multiplying both sides by 4, we've canceled out these two numbers. The 4 on the top cancels out with the 4 on the bottom. And then 8 times 4 is going to give us 32. That's our final answer. So this was a two-part question where you had to find k first and then use k to find a missing variable. But if you plug in all your numbers in the right orders at the right time, you'll be able to figure it out no problem. Okay, the last problem we're going to go over today is number 3. All right, so number 3 says, suppose direct variation. So suppose direct variation is modeled by y equals 7x. Y equals 7x. What is the slope? What is the slope of the line graphed by this equation? What is the slope of the line graphed by this equation? This is going to be the easiest question for you. Since it's y equals 7x, the answer is going to be 7. It's always going to be the number in front of x. So if you have y equals kx, k is the slope. K is the slope. Because the number in front of the x, usually in slope-intercept form, y equals mx plus b. The m is always going to be the number in front of x, and that's going to denote the slope of the line. So the slope of this line is going to be 7. Notice, they didn't tell us anything about a y-intercept. We don't need b. We need to know what m is. And we know that m is going to be 7, which is the same thing as k. All right?